So a couple days ago I was watching this video that Numberphile made about this thing called the game of life. And I thought it would be really interesting to model in computer programming. And anyway, so if you don't know what that is, there's a couple links. There's a Wikipedia page on it that I'll leave a link to in the description. There's the Numberphile video about it, which I'll also leave a link to in the description. And I'll probably be putting an annotation on the screen right about now that will lead you to that video. So anyway, so I have a little bit of setup here. I have a room. I run it and I get this grid. It's just graphical. It doesn't do anything. Nothing happens when you click on it or nothing like that. I also have this piece which currently doesn't do anything. It has a sprite. There's the sprite there. It's not important. I won't talk about it. Anyway, the game of life, if you don't already know, is quite simple. It was originally devised to, I believe, model something like a self-replicating machine, a theoretical machine that could self-replicate itself, and it was like population growth and stuff like that. I should talk slower. It would be a lot easier. It would make a lot of things a lot easier. So you have a piece on a grid, and it's, according to the game of life, it's actually an unbounded grid, meaning that it's infinite. But for the purposes of this, for all practical purposes, we're just going to be working on a grid that's the size of this room here. Anyway, so you have pieces, and they have neighbors. So the neighbors are the 8 squares around the piece, so up, down, left, right. I got the backwards and the corners. And the way it works, it's a 0-player game. Once you set it and let it go, it doesn't need any further input. It just operates on its own. So the way it works is if a piece has 4 or more neighbors, then the piece is overcrowded and it dies. If the piece has, say this is our piece, if it has 1 or 0 neighbors, then it gets lonely and it dies. Let's delete it like that. And if there's an empty square with exactly 3 neighbors, then a piece will spawn there. And that's basically it. It plays itself, it runs on its own. So I'm going to be modeling that here. So first thing, I have this runner object, and there's this draw event, which just has code to be drawing the lines on the board. If you don't know what that looks like there, that's that. I think to be starting off, we will want to, in the create event of the runner, have a board object, not necessarily object, but array, and it'll be 2 dimensions. It'll be very much like the array of pieces on the chessboard tutorial thing that I made a couple months ago now. I'll probably be talking about that a few times. If you're not sure what that is, I guess I'll put a link in the description to that video too, so you can go see that. I thought it turned out to be an interesting video, but whatever, series of videos. Anyway, so if I can spell. We're going to be basically setting up 2-dimensional for loop. I don't think I have to show this on recording. 2-dimensional for loop, O of n squared as it were, and we're just going to say, if I can spell out too, the board of I and j equals no one. So basically setting it to null. Just GM just knows that it's that index in the array is there, so you won't get any crazy index out of bounds errors if you're trying to talk about that. Okay, so that's simple enough. Run the game, nothing will happen, and I should hope that nothing happens because it has a variable, but it doesn't do anything with it. So now into the pieces. When the pieces are created, we're going to, for good measure, in my implementation of this isn't necessary, but someone else could take this and mess around with it. So I'm going to say move snap 32 and 32. So it's going to snap to the grid. It's not going to be like at a halfway point or anything. Also, we're going to be wanting it to put itself in the grid. See, I did this yesterday. I actually recorded this before, but I didn't like the way the recording came out. I kind of have an idea of what I'm doing here. Anyway, we're going to be saying temporary position variables. I like those things. Let's see, x integer division 32. So this is redundant because it's already snapping it to 32, and then you're basically dividing and rounding it down. But the remainder is already going to be 0. But once again, I think just to be safe, it barely adds anything to the code. So I'll just leave it there anyway. Once again, if someone else tries to play around with it, then hopefully it won't die immediately. Anyway, so we're going to be saying if No, not quite yet. With that, I was going to be going checking to see if the position in the board was occupied or not. But first, we're going to want to make sure that that position that's in the board already. So now, this is where we're going to be making our first function. It would be really lovely if we could say if place on board and pass it that, and then be doing something. So unfortunately, at this moment, we don't have a function like that. So we're just going to go and make one. Place on board, and this little function signature is going to be Boolean because it returns true or false. Place on board, and it's going to take an X and a Y. And as always, when you're trying to use arguments and functions in GM, it looks a little bit weird if you're coming from a background of like other programming languages. There we go. So now it has its two arguments, x, x, and y, y. Now, this is just going to be a simple statement. It's going to make sure that the place is on the board. So if x is greater than -1 and y is greater than -1, and it's within the outer boundaries of the array. So if x is less than or equal to room width divided by 32, and basically the same thing for y, then we're going to return true. Else, that's not how you spell else, that's not how you spell else either, else we're going to do that. Technically, if you're good at computer science and you're watching this, you'll note that you can just say return this. And I probably would normally do that if I was just programming on my own, but I do want this code to be readable for other people, so I'll just go with a longer if-else block statement. So if you're using another language, you could probably use a ternary operator too, but unfortunately GM doesn't have any of that. Anyway, we now have this function, if place on board, then we're going to be putting it in the board, or what we probably will be anyway. Runner.board xx and yy equals no one. If there's no other piece there, then we are quite simply going to be putting ourselves in that position. That's not how you spell ID. Else, there was no need for this, so we're just going to delete the instance. My fingers are cold, so my fingers are cold, so my typing is going to be even messier than usual. And otherwise, if the location isn't on the board, then pretty obviously I think we should delete it there as well. Save the game. I probably should save this just in case. I don't know. Say I get a lovely blue screen or something of that nature. So we're just going to say game of life. Save it. Be done with that. Let's put you on the board. I just saved the game compulsively, didn't I? And yes, you will notice that about me if you don't know already. I do hit Control S quite frequently. I'm a compulsive saver. Anyway, so anyway, now this thing is in the board array, but it doesn't really do anything. And the reason for that would be that there are no rules governing it. Now, this program, the Game of Life program simulation, as it were, it's actually pretty simple, and I like to think that we're already halfway finished with it, although the second half is more complicated than the first half. Anyway, so basically, on every time interval of a given length, it's going to update, and it's going to follow the rules that I had stated earlier, which is like if it has not enough neighbors, it's going to die. If it has too many neighbors, it's going to die. If it has 3 neighbors exactly, if an empty square has 3 neighbors exactly, you'll find a piece spawn on it. That does generate a lot of jokes, usually like an organism having 3 parents, but I won't get into that. I know some people will find that particularly funny. Anyway, let's see. So the best way to do this, I might as well test this. So in the step event, just to prove that, just to get something going, I'm going to be banging out a couple lines of code real quick there. This is just to test it, to see that the loop, the step event loop, is working as it should, and it's just going to generate a random x position and the random y, and it's going to be within the board, and then it's going to create a piece there. And this looks kind of redundant because it's dividing by 32 and then multiplying by 32, but you don't really need it because of the move snap thing. Put in the pieces create event, but just once again to keep it clean. Anyway, we run this, and alright, so we run into our first error. There's always a couple of those. Index out of bounds. What I'm pretty sure is happening is that should be less than or not less than or equal to, because of the way this loop sets up. Yeah, I'll leave it like that. It doesn't really matter the specifics, whether that goes say to the edge of the board. Yeah, that looks like it goes to the edge of the board. If I'd made it less than or equal to, it would have gone one over to the side of the edge of the board. Anyway, so that's going to populate. You can sit there watching it if you really want to. I don't really want to, so I'm just going to get out of that really fast. Why do I have... I should probably not be having that on. I was recording something else earlier. But anyway, that works. Now, instead of this, we're going to be, I think, looking at every position on the board. So, once again, the for loop. I'm just going to copy and paste the for loop from here because I don't like typing. You will learn that very fast on me. I don't like typing. If there's a way I can simplify something, I probably will. Not to the point of it being unreadable, like I said before with the short return statement, but whatever. Anyway, so instead of this, we're going to be checking each position. And this kind of made me trip up a little the first time I was doing this, because you want the whole board to update simultaneously. I kind of wish I had like a pen and paper to write it down with here, but I'll just show you what could very easily happen if you're not careful, if you're not thinking about it right, and you'll end up getting a lot of weird errors, is that you look at each square simultaneously. So say you have, I don't know, a random arrangement like this, then you look at this piece, say it has exactly 2 neighbors, you'll move on. This square here has exactly 3 neighbors and it's not occupied, so it'll create something. Then this has exactly 2 neighbors, so it'll be left alone. Then this has 0 neighbors, so it'll get deleted. Then this has on and on and on, and each position will update based on the current state of the board, and not based on the last state, and it won't be simultaneous. And I hope you understood what I just said there, because honestly I'm not sure if I would have. Anyway, point being, we have this loop, and we're going to look at each square. If runner.board, I don't need to say runner because this already belongs to the object that has runner, so the visibility is the scope. It knows where to look for board. If the I and j is equal to no one, what did I do to that curly brace? Then you'll do something else. You'll do something else. Yay, skeleton code. Now inside this, if board I and j, no, not quite. If the square has a certain number of neighbors, if it has exactly 3 neighbors, then you'll do something. So once again, it would be nice if we had a little function for that, which we don't. So we'll make one of our own, and we'll call it, say, something like number of n, and we'll pass it to I and j, and we'll do something with it. And ignore the syntax highlighting there. I'll make that function in a minute. I just want to finish filling this out. Else if double equals. Not that it matters in this language, but it's good practice. Else if there is a piece at a location. Really sounds familiar to that chess tutorial. I said that way too many times in that video. But if there is a piece at the location, if number of n at that position is less than 2, then you'll do something else. If number of neighbors is greater than 3, then you'll do something. Else you won't do anything. Else don't do anything. I'll just leave that alone. Alright, so now we'll tackle the missing function there, and that would be, we'll go over here, create a script, number of n, and signature is going to be number of n, and it's going to take an x and a y. By the way, the 3 comment slashes here instead of the usual 2, in GameMaker Studio of 1.2 and onwards, if you can do a triple slash at the beginning of a function, and in the argument help, like if you're to say something like this, you see the argument help down here below the error message, you'd get that to pop up. So whatever you put in your own custom functions, but that's not supported in 8.1 or before Studio 1.2, but it's not a bad idea anyway. In general, you should always, like, if you're in GameMaker, you should always put some sort of a signature at the top of your functions anyway, so in case you do forget, you can just come over and look it up. Anyway, that aside, I get off topic a lot if you haven't noticed. We're going to take the arguments. I'm just going to copy and paste the argument notation from over here because, once again, I'm lazy and I don't like typing. And we're also going to have a little variable called n for the number of neighbors, and we're going to initialize n equals 0. And then we're going to, I can't think of a way, I've thought about this for a few days, and I can't think of a way to soft code this. And by soft code, I mean write an algorithm instead of copying and pasting a similar line of code like 8 times to check each position around the location in question. But if anyone can think of that, put it in the comments. I will thank you a lot. I really like algorithms. I don't like copying and pasting code at all. But anyway, we're just going to say if place on board, and the x, I'm going to do this a couple times, but x minus 1 and y minus 1. I'm getting thirsty, I need to drink some water. If runner board, if the value at that position in the board is not equal to no one, then increment n. Alright? And I'm just going to copy and paste this 8 times. By the way, if anybody is confused about my use of curly braces here, I use them here, but not here. Generally, I don't like using curly braces because they make my window of code more messy than it has to be. But at the same time, if you don't use any at all, if you use the minimal number of curly braces, it will get a little messy. So in this case, you have these 2 lines, and you can pretty much tell where the scope of that is. It's a single statement after an if statement. But this one, technically it's also a single statement after an if statement, but it's harder to tell because it's spread over multiple lines, so I will put curly braces around that. Anyways, I was saying, we're going off topic again, and there's a lot of noise in the hall. Alright, so I have that 8 statements, and they represent each of the locations around the space in question that we'll be looking at. And then at the end, I'm just going to return n. Now, if you wanted to test this, you could probably make a similar loop in the draw event and draw at each location the number of neighbors, piecewise neighbors that it has, and you'll get something that looks like a Minesweeper board. I did that a fair amount when I was testing this yesterday, but I'm not going to do it today because it'll take a little bit longer to write than I really want to. Anyway, we'll go back in the step event. If the number of neighbors is if the number of neighbors equals 3, I forgot to write that the first time around, then we'll want to do something. Now, I could just very easily say instance create a piece, but that'll get back to what I said earlier in that it'll update sequentially instead of instantaneously, and while once again that can provide some interesting looking behavior, it doesn't follow the rules of the game of life. So we'll have to do a little bit more than that. Now, the solution that I got would be to create a list of positions that are changed. And by that, I don't mean GameMaker, for those of you that don't know, actually provides a library of built-in data structures, one of them being the list. So you could say ds list create, and then you'll be able to add stuff. But that is a GM standard only function, and I want this to be accessible to everyone and not just the people using standard. So I'll just kind of be building my own. So the list, we're going to initialize here, list equals 0, just to put it in memory. And the list size, because we're going to want a variable for that, because unfortunately GameMaker doesn't implicitly know the length of every array. That's also going to be 0. Alright, so here in the update loop, actually I'm not going to put that in the create event. Don't listen to me. I'm going to, wrong symbol, I'm going to put that in the beginning of the step event so that it's going to, all the action is going to happen here anyway, so there's no need to put it somewhere else, and it's going to be reset to 0 in every step anyway. List of no, not entirely. A list of list size 0. That's going to be the x, so we're going to say that's I. And the list of 1 is going to be j. So it's basically a set of pairs that represents the coordinates on the board. So we're just going to do that there and there. So I could stack this all in one if statement over there because it's basically the same behavior, but once again, readability. So you have this list of values of stuff that updates. Now what to do with it? So I'm just going to make this code window full screen for the time being. So after you're done with this, it'll be just checking the conditions of everything and adding the necessary values to the list. This is basically the list of positions in the board that are going to be changed in case I haven't said that already or if you haven't figured it out for yourself. But what we're going to do with that is we're going to once again set up a loop. I equals 0 and I is less than list size and I plus equals 1 and the curly braces, and if board of list of I and 0 and list of I and 1. This looks like a complete mess, I know, but I'll explain it when I'm finished. If that equals no one, so if there's an empty square, then that will mean that it's surrounded by three neighbors, and it can have something spawn on it. Then instance create. I'm just going to copy and paste that because I'm lazy still, and we're going to multiply by 32 because if we didn't, that's referring to places on the board and not on the screen, so they'll all be bunched up in the corner. Then you're going to do that. Otherwise, and if you're not following this, don't worry. I will explain it more in a minute. Else, I'm going to want curly braces because there's going to be more than 2 statements in this block. Else, with, that's the lowercase w, good, board of, once again, this position. We're going to delete that instance, and it looks like I'm missing a square bracket somewhere there, and we've deleted the instance that died because it's either too crowded or it's too lonely. And then we're going to just set the board of that position equal back to no one. Okay, so this is a little bit confusing. Some people may not see the connection between just adding the position to the list and then somewhat arbitrarily changing it. Well, I'll try to make this quick. If it's added to the list, this is a binary set of operations. So there's either 2 possible states. There's something there or there isn't something there. Call that cheating if you will. Maybe you'll want to set up a third entry in here, and it'll hold like the action that you have to take. I don't know if you can throw down here if it says create. Then create something else. If it says destroy, then destroy something. I don't know, but the point is, if the position is being added to the list and the location is empty, then the only possible thing that could be going on is that there are the right conditions for a piece to spawn there, and otherwise, if there is a piece there, the only reason it could be added to the list is because there's the right conditions for the piece to be deleted. So I hope that made more sense to those that didn't get that. gonna save the game again. I'm gonna run this for the first time since ever. There's no pieces on the board. Actually, yeah, there's no pieces on the board. To test this, I'm going to create what is known as the glider pattern. There's actually a set list of patterns that repeat themselves over the course of the program. And I'm also going to set the speed to something like 10 so it doesn't go absolutely haywire. Let's see, that is not moving. Alright, what's going on? I probably shouldn't have only tested it once. Alright, so I found the problem, and they're actually pretty obvious. One is that this is looking at X and Y, not XX and YY, and that's a pretty silly mistake. Give me a minute to correct all this. Alright, there we go. You'd be surprised how long that took me to figure out. But anyway, the second error is that in runner step, we weren't updating list size every time we added something to the list. So it was basically, whoa, that's not what I wanted. It was basically down here saying list size still equals 0, and therefore for I equals 0, I is less than 0, I plus equals 1, and none of this was actually happening, and that wouldn't have mattered because there wouldn't have been all that much in the list array anyway. Anyway, so I fixed that off screen. Let's run that again. That should work. I misspelled a variable. I love misspelling variables. Not that. Yeah, there's another thing there. I don't know if that was while I was messing around trying to fix this or if I mistyped that at the start, but it doesn't matter. Yeah, you can't. There are some values that you can't give variable names to. And yeah, that's just a set of pop-ups telling me stuff that I was using in the test earlier that I might as well take out. That's another thing that I could make a game maker video about. It's like debugging stuff, using show message to trace errors through a program and fix stuff. Anyway, so as you can see, this is crawling across the screen, and it died. That could be because there's something wrong with my starting position, or there's something wrong with the code. And I'm kind of leaning towards the second position because I'm pretty sure the starting position is right. Let's see. Oh, that would explain it. Yeah, that one was still not changed to Y. That would be an issue. Alright, so I'm going to set the run speed a little bit higher than 1 frame per second. Now I'm going to go back to 10 so that it's moving, but it's not lightning fast. And yes, as you can see, that is crawling across the screen like it normally would. It hit that and stopped because the grid is bounded, but that's fine. If you want, you can download this file. It's going to be somewhere zipped in the description of this video and mess around. If you want, you can make this like 4,000 by 4,000, and let's try this. That looks really weird, but it's also lagging because it's I think this is lagging a little bit because it's so big and it's drawing so much, but that'll run for a while. Yeah, let's not do that. I don't want to kill everyone. That's not anything. All right, but yeah. That was really pretty simple. That didn't take too long, although there was a little bit of annoying debugging for me misspelling variables. If you want, you can just take as many of these as you want and just throw them. I deleted something important, but yeah, you can just throw as many of these on the screen as you want. Make up any random configurations. Watch it, see if it loops. You might want to make the speed a little higher if you want anything to happen in any interesting amount of time. As you can see, that one there has part of it's moved off the screen, and part of it's gotten down to what's known as a replicating pattern. I can't see entirely what's happening there. I hope that's not like a glitch, because that looks really a glitch in this logic, because that looks really strange. But there are some patterns that will reduce down to some basic. Do I still have the Wikipedia page open? Nope, I don't. Some basic patterns, like the block. The block is not replicable, and by that I mean, like, if you look around it, nothing should ever die, nothing should ever be created. So you can mess around with that. The links will be in the description. Once again, GameMaker 8.1 and Studio, Light and Standard, doesn't make a difference. This is a very basic program. Sorry for the cut there. Somebody interrupted me momentarily. Yeah, you could even probably take this and translate it into another programming or scripting language without too much effort once you have the basic logic down. But once again, I've been rambling on here for long enough. That's dead Chrome browser with no internet access. I hope you all enjoyed that. Rate, comment, subscribe. Watch some other stuff I've uploaded. I do other Game Maker stuff from time to time, although my usual stuff is gameplay related of other video games. And yeah, I will see you later.